Hi everyone. Have you ever wondered how AI agents like Perplexity, GPT actually work under the hood? How they can think, search the web, remember conversations, and even ask for human approval before taking critical actions? Well, today I'm going to break down everything you need to know about LangGraph, the framework that's powering the next generation of AI agents. I will start with the first topic, code. It is the very first level of autonomy in LLM applications. Code has zero autonomy and is 100% deterministic. We all know that everything is hard coded and it is not even really a cognitive architecture. So, what's the disadvantage? The problem is you would need to write rules for every possible scenario, making it impossible to handle real life complexity. Think about it. If you want to handle all different ways user might ask a question, or all the different edge cases in your application. You would have to write explicit rules for each one. That's simply not scalable. This brings to the LLM. Now, let's look at the next level, which is a single LLM call. A single LLM call means your app basically does one main thing. You give it an input, it processes it, and it gives you back an output. Think of chatbots that just takes your messages and respond, or apps that translate next text. This was huge leap from hard-coded rules. Even though it is still pretty simple and it is only in the second stage of autonomy, here is how it works. The user gives an input to the LLM and then the LLM gives an output. For example, the user might say, "You are an expert LinkedIn post writer. Write me a post on AI agents taking over content creation." The user is giving just one prompt, one particular task to the LLM. And the LLM is pretty good at doing that one particular thing. But here is the disadvantage. Trying to get everything done in one shot often leads to confused or mixed up responses. Just like how one single person cannot be an expert at everything. If you tell the LLM to do multiple things in one prompt, it's not going to do it really well. This disadvantage is overcome in chains. This is the next level of autonomy called chains. Think of chains as having multiple specialists instead of one generalist. Instead of asking one AI to do everything, we break it down into steps where each AI is really good at one thing. Let me give you an example. Imagine a customer service chatbot. The first AI reads your complaint and figures out exactly what products you are talking about. The second AI finds the right solution from the company's help docs. And then the third AI turns the solution into a friendly response. Each step is simple, but together they create a much smarter system than a single LLM call. This is where we first started seeing AI applications that could handle more tasks, not just by being smarter, but by breaking big problems into smaller, manageable pieces. But what are the disadvantages of chains? The downside is that these fixed sequences are like a rigid assembly lines. They always follow the same steps defined by the human. Looking at the example, if the user wants a LinkedIn post, a Twitter post, and a blog post, we create three parallel chains. One chain for LinkedIn, one for Twitter, and one for blog post. The disadvantage is that we have three specialists instead of one generalist. But the downside, the level of autonomy is very less. It is not making an intelligent decisions. We define the direction and it just follows the path without any real thinking happening. Now, router comes into the picture. This is where it gets really interesting. Let's look at routers. Routers are like smart traffic cops for your AI. Instead of having a fixed path like in chains, the AI itself decides what steps to take next. Imagine a personal assistant bot. When you ask it something, it first figures out if you need help with scheduling, research, or calculations, and then routes your request to the right tool or chain for the job. Here's how it works. The user input goes into a router LLM first. The router LLM looks at the user's request and decides, is this for LinkedIn? Is this for Twitter? Is this for blog post? Based on that decision, it directs the control flow to the appropriate chain. So if the user asks for LinkedIn post, the router LLM identifies the LinkedIn and sends it to the LinkedIn chain. This is the key difference from chains. In chains, there is no real intelligence happening, but in a router, the LLM is actually making a decision based on the user input. But there is another disadvantage with routers. While it can choose different paths, it still cannot remember previous conversations or learn from mistakes. There are no cycles, meaning once it goes down a path, it can't come back and refine something. The control flow is still one directional. And this brings us to exactly why we need the next level. Let me show you how this works in practice with a head of content agent. The user only has to deal with the head of content agent. The user can say, write me a LinkedIn post on this topic, or write me a Twitter post, or even write me both. This is how it works in business. You have one high level supervisor that you give all your instructions to, and the supervisor has multiple people under them who actually do the work. The head of content agent looks at the user's request and decides, does it need to talk to the LinkedIn scriptwriter agent? Does it need to talk to the blog post writer agent? Does it need to talk to the social media publisher agent? And here is where it gets powerful. We can add human in the loop. Once the LinkedIn script writer agent is done, we can have an approval step. The draft goes back to the head of agent when asked, is this good? Do you want any corrections? If the user says make it shorter or add a better hook, the feedback goes back to the LinkedIn script writer, which already has context of what it generated before. It makes improvements and the cycle continues. This is time travel ability. It can go back and interactively make something really good. Comparing chains, routers versus agents. Now let's understand the key difference between human driven and agent executed. A chain or a rotor is just one directional, hence it is not an agent. In a state machine, we can go back in the chain, have cycles, and flow is controlled by the LLM, hence it is called an agent. In chains and rotors, we saw that it starts from left side and just keeps going to the right until the end node is reached. But in state machines, there are loops happening, there is a time travel happening, there is a human review happening. The user can critique something and it gets regenerated. This is actual intelligence. The very similar to how you would do things in real world. Just like having a content writer under your, there are multiple interactions happening. That's why state machines are called agent driven. Whereas chains and routers are considered dumb. Even though there is an LLM involved, the LLM is not deciding the control flow. Now let's understand the AI agents and tools. Agents are problem solvers. They are capable of thinking on their own, AI that can make autonomous decisions. In chains and routers, they follow our specific instructions. But with agents, they actually take it a step further. They can decide for themselves what steps to take. We have to know about the tools. Tools are specific functions that agents can use to complete tasks, just like a chef's kitchen tools, knife for cutting, oven for baking. Tools are specific abilities we give to AI like a calculator tool, search engine tool, or calendar tool. Now, how do we create an agent? Here is a very popular pattern called React Agent pattern. React stands for reasoning plus acting. This is basically a concept that mimics how human beings think. The pattern works like this. Think. The LLM thinks about the user's prompt or problem. Next, action. Decides if it can answer itself or should use a tool. Next, action input. Provides the input arguments for that tool. Observations. Observes the output of the tool. This cycle repeats until the final answer is found. Here is a simple way to visualize it. LLM as brain plus tools equal to agent. Whenever there is an LLM, the reasoning ability, the brain, and you equip the brain with some tools like the ability to make API calls, do a Google search, or run a Python functions. Combining both together gives rise to an agent. The think, action, observation loop continues until the problem is solved. Just think like how humans first think about a problem, take action to solve it, observe the results. If not solved, think again and repeat. But there are drawbacks to React agents. React agents are very flexible. Any state is possible. The agent might execute tool 1 first or tool 2 first or any order. This flexibility is powerful, but high flexibility can also mean less reliability. The main problem is infinite loops. The tool keep getting called again and again forever. So we have chains on one hand, less flexible but more reliable. And we have React agents on the other, very flexible but less reliable. We need something that has the best of both worlds, flexible and reliable. And that is exactly where LangGraph comes into the picture. So what is LangGraph? LangGraph is a framework for building controllable persistent agent workflows with built-in support for human interaction streaming and state management. It uses the graph data structure to achieve this. Why use the graph data structure? Because many researchers papers solving difficult problems use graphs. They are flexible but controllable, giving you autonomy while still being manageable. Now let's dive into reflection agents. First, what does reflection means? Just like looking at your reflection in a mirror, it means looking at yourself or your actions. For example, after giving a presentation, thinking about how it went. After writing an email, reading it again to make sure it's clear. After making a decision, considering if it was the right choice. A reflection agent pattern is an AI system that can look at its own outputs and think about them or make them better, just like how we look at ourselves in mirrors and self reflect. There are thinking systems. System 1 normal prompting, very fast, subconscious, automatic, good for everyday decisions, but error prone. System 2 reflection pattern, slower, more conscious, effortless, better for complex decisions, more reliable. Here is a practical example. A tweet generation system using reflection. A basic reflection agent system consists of generator agent, a reflector agent. Generator agent creates the tweet, reflector agent critiques the tweet. How it works? First, the generator agent creates a tweet based on your topic. Then, the reflector agent looks at and says, "This is too long, make it shorter and better hook." This cycle repeats 4 to 5 times. With each interaction, the tweets get better and better. It's like having a content editor who keeps polishing your work until it's viral worthy. Generate, reflect, revise, repeat, final output. Here, the LLM generates an initial response, and the reflect, another LLM reflects on it, providing critiques and merit points. Revise. The first LLM incorporates the critics and generates a better version. Repeat. This loop continues n times. Final output. After enough interactions, the refined result goes to the user. The power is in the interaction. Rather than one shot response, we get thoughtfully refined outputs. There are three types of reflection agents in LangGraph. Basic reflection agent, what we just discussed. Reflection agents builds on top of basic reflection by adding external data. The content is grounded in real, live data with citations. And the last one, language agent tree search. The most advanced type explores multiple paths like a tree, evaluating different approaches before choosing the best one. Let's dive deeper into reflection agents. The problem with basic reflection, the content generated is not grounded in live data. It could be a hallucination or outdated content. For example, if you want a blog post on how AI is helping small business growth, a basic reflection system would write based on training data that might be year old. But for an enriched blog post, you need recent news and data with citations. The reflection agent addresses this by adding tools for external data. Here, the components of reflection agent are actor, responder, tool execution, revisor agent. Actor is nothing but the agent that drives everything. Responder agent generates initial response plus critique plus search terms. Tool execution makes API calls to get live data. Revisor agent re responds based on the new data with citations. The responder agent is the first subcomponent. When a user requests a 250-word blog post, the responder outputs a JSON structure with three properties: response, critique, search terms. The actual 250-word blog post content given by the response and critique, self-critique of what it just wrote. This could be better, too much redundant info, missing examples. These are inside the critique. Search terms. List of keywords to search for more information, like AI for small business 2024, AI tools for growth. These will be in the search terms. Mm. So, in one shot, it writes the content critiques itself, suggest what to search for improvements. Here is the complete reflection agent flow. The responder generates response plus critique plus search. The tool executions like Travelly Search fetches live data for those search terms. Revisor receives both the initial response and the new live data. Revisor creates revised response plus revised critique plus new search terms plus citations. These citations are like research paper references. They point to the actual URLs where facts came from. The loop repeats. The revisor might want more information. Tool execution fetches it. The revisor improves again. With each interaction, contents get enriched with live data. More citations are added. Quality keeps improving. Now let's talk about building chatbots with LangGraph. The simplest chatbot has a basic graph structure: start, chatbot, end. The flow, the user messages, the chatbot processes and responds. This is a foundation but not make it powerful. We need to add more capabilities. Now, next chatbot with tools. Here, the next level, the agent can receive user message, decide if it needs to use a tool, execute the tool, get results, formulate the response. There is a conditional edge. If the tools are needed, go to the tools node. If the node don't need the tools, go directly to the end. This is where the chatbot becomes truly useful. It can search the web, calculate things, access databases. Now for the important part, memory and the checkpointers. The problem, regular chatbots forget everything after each conversation. Like if I say my name in the first conversation and then ask my name again in the next conversation, it won't remember. Checkpointers solve this by automatically saving conversation state, persisting between sessions, enabling thread-based conversations. With checkpointers, your chatbot remembers past conversation and can resume exactly where you left off. The final powerful feature, human in the loop. This allows human interventions at critical points in the agent workflow. Some actions like irreversible, you want human oversight before critical decisions. Compliance requirements may need human approval. LangGraph provides built-in support for human in the loop through interrupt points. There are typically three different actions that you can do with a human in the loop workflow. The first one is approve or reject. Depending on the human's approval or rejection, the graph can proceed with action or take an alternative path. The second one, review and edit state. A human can review and edit the state of the graph. This is useful for correcting mistakes or updating the state with additional information. The last one is review tool calls. A human can review and edit the output from the LLM before proceeding. This is particularly critical in applications where the tool calls requested by the LLM may be sensitive or require human oversight.